In this video, we are differentiating functions with two or more terms. The first question, differentiate y equals 3x to the power of a third minus 2x to the power of negative 3 plus 5. So dy dx is our gradient function. And to differentiate, we're going to times by the power and then take one off the power. So 3 times a third, that's 1. And then we've got x to the power of a third, take away 1, which is minus 2/3. The next term, times by the power, negative 2 times negative 3 is positive 6. And then we're going to take 1 off the power, negative 3, take away 1 is negative 4. The next term is 5. 5 is just a constant. It has no gradient. So that part goes. It's 0. One for you to try. Pause the video. Give it a go. So y equals 6x to the power of 3 over 2 plus x to the power of negative 2 plus 2x. So our gradient function is dy dx. We're going to differentiate one term at a time. Times by the power, take 1 off the power. So 6 times 3 over 2. 6 times 1.5, that's 9. Take 1 off the power, 3 over 2, take away 1 is a half. Move on to the next term. X to the power of negative 2 times by the power, so that'll be negative 2. And then take 1 off the power, so negative 2x to the power of negative 3. The next term is 2x. That part has got a gradient of 2. So that is our answer. This time we've got a question that we need to put into the right form before we can differentiate it. So I'm going to write y again. So the cube root of x, I'm going to change to x to the power of a third. And 1 over 2x, I'm going to change to half. And then the power of x is going to be negative 1. 1 over x is the same as x to the power of negative 1. So it's half x to the power of negative 1. Now it's in the right form to differentiate. So we can say dy dx is equal to, and then times by the power, take 1 off the power. So x to the power of a third times by a third. So 1/3 x, and then take 1 off the power. A third, take away 1 is negative 2/3. Half x to the power of negative 1 times by the power. Half times negative 1 is negative a half. And then the power is negative 1, so take 1 away, that becomes negative 2. So minus half x to the power of negative 2. And that is our answer. One for you to try. Pause the video, give it a go. So firstly, let's put it in the right form to differentiate. So a square root x, I'm going to change to x to the power of a half. And 1 over x squared, that's the same as x to the power of negative 2. So now it's in the right form, we can differentiate. So times by the power, take 1 off the power. So 3 over 2x to the power of minus a half minus 2x to the power of negative 3. Another one. So y equals x squared plus 2x minus 5 all over square root x. So we need to get rid of this fraction before we can start. Square root x is the same as x to the power of a half. And when we've got 3 terms divided by 1 term, we can divide them all separately. So x squared divided by x to the power of a half. When we divide indices, we take away the powers. 2 take away a half is 1.5, or 3 over 2. 2x divided by x to the power of a half. So 1 take away a half is a half. That's 2x to the power of a half. And we've got minus 5 divided by x to the power of a half. So we've got x to the power of 0. Well, 0 minus a half is minus a half. So it's minus 5x to the power of minus a half. So now it's in the right form. Now we can differentiate. So times by the power, take 1 off the power. So dy dx will be 3 over 2x to the power of a half plus 1, so I won't write that, x to the power of minus a half, and it's a minus times a minus, so plus 5 over 2 x minus a half, take away 1 is minus 3 over 2. One for you to try. Give it a go. So again, we need to divide through by x to get rid of the fraction. So 5x cubed over x is 5x squared. Negative 4x squared over x is negative 4x. And negative 7 over x is negative 7x to the power of negative 1. Then we can write out dy dx times by the power, take 1 off the power. Negative 4x has got a gradient of negative 4. And times by the power, take 1 off the power. So dy dx is 10x minus 4 plus 7x to the power of negative 2. This time we've got a bracket. We can't differentiate it in this form, or we don't want to. So we are going to expand the bracket before we differentiate. So y is equal to 3x cubed minus 2x squared minus x. Then we can work out our gradient function. So times by the power, take 1 off the power. Times by the power, take 1 off the power. And times by the power, take 1 off the power. So dy dx is 9x squared minus 4x minus 1. One for you to try. Give this one a go. So let's start by expanding the bracket. So we've got 2x to the power of 4 plus 6x cubed. So dy dx is going to be 8x cubed plus 18x squared. Find the gradient of y equals x times x squared minus 5 at the point 2, negative 2. So when we need to find the gradient at a point, we find the gradient function first and then substitute in the x coordinate. So let's expand the bracket before we differentiate. So y is going to be equal to x cubed minus 5x. Now it's in the right form to differentiate. We can find the gradient function. So times by the power, take 1 off the power. So dy dx is 3x squared minus 5. So when x equals 2, that's our x coordinate. What is dy dx? What is the gradient? So we've got 3 times 2 squared, take away 5. So 2 squared is 4, 3 fours are 12. 12 take away 5 is 7. So the gradient is 7 at that point. One for you to try. Give it a go. So we need to put it in the right form to differentiate first. So we're dividing through by x. That leaves us with 5x minus 3x to the power of negative 1. Then we can find dy dx, which is going to be 5 plus 3x to the power of negative 2. When x is 1, what is dy dx? That's going to be 5 plus 3 times 1 to the power of negative 2. That's the same as 5 plus 3, so it is 8. And another question, find the points on the curve, y equals x to the power of -1 plus 9x, where the gradient is 0. So where dy dx is equal to 0. So let's find dy dx, the gradient function, first. Dy dx is going to be equal to -x, the power of -2, times by the power, take 1 off the power, plus 9. And then where is that equal to 0? So where is -x to the power of -2 plus 9 equal to 0? I'm going to rewrite my x to the power of -2 as 1 over x squared. Then I'm going to plus that to both sides, so plus 1 over x squared to both sides. So 9 equals 1 over x squared times by x squared. So 9x squared equals 1. Divide by 9, so x squared is a 9th. And then square root. So x is going to be plus or minus the square root of a 9th, which is plus or minus a third. So they're the x coordinates, 1/3 and minus a third. If we want the y coordinates as well, which I think we do, find the points on the curve. So y is a third to the power of -1 plus 9 times a third. A third to the power of -1 is 3. 9 times a third is also 3. So y would be 6. So 1/3, 6. If y was minus a third to the power of -1 plus 9 times minus a third. Minus a third to the power of -1 is -3. 9 times minus a third is -3 again. That's -6. So it's either 1/3 6 or minus a third -6. So they are our two answers. Here's one for you to try. Pause the video, give it a go. So find the point on the curve y equals x squared plus 8x, where the gradient is 0. So we want to find dy dx, our gradient function, which is 2x plus 8. Where is that equal to 0? Where 2x plus 8 equals 0. That's where 2x equals -8. That's when x is -4. So when x is -4, y is -4 squared plus 8 -4s. -4 squared is 16. 8 -4s is -32. So that's -16. 16 take away 32 is -16. So the point is -4, -16.